Okay, so update on Mazequest 2, the new build here. I have been working furiously for the past maybe 5 days trying to get the AI working on this, and I just thought I'd show it off a little bit. I finally got something that I think is kind of acceptable, or at least the beginning of something that's acceptable. And let's see here, let's go ahead and hold on, let me do this again. Let's put maximize on play here. Get a little bit bigger screen. There you go. Okay, so here we go. And not too much has changed except for the battle mode. Quite a bit has changed on the battle mode. So let's go back to the Amazon because it's kind of it's kind of obvious who I am then. Okay, so this is the battle mode, and this has already been shown, I'm pretty sure. Let's just put this unit over here. Okay, so these are the enemies, this is me, and we're going to check out their AI here. Basically, we hit the defense button there, and okay, so they're kind of moving toward me, as you can see. They should move all the way toward me here. Yep. But at the same time they move toward me, and let's see if I can split them up here. They should kind of stay in a group, right? So, oh, I get another turn here. But it's kind of hard to split them up a little bit. It's since there's no reason that they would kind of split up anyway. But you notice they're kind of staying together. Okay. I'm very proud of this, by the way. This is, well, in my opinion, it was pretty clever how I did this. But anyway, we'll go ahead and let them actually reach me here and see what they do. So this guy's going to hit me with a spell. That's what a spell looks like now. That's that like little animation there. That's temporary. Okay, so they all killed me, apparently. Let's go heal up. And here we go. Ooh, there's a little something that happened there. I'm not sure what that was all about, but I think that was probably the grid resetting is what that was. There's a little flicker there that shouldn't have been there. But anyway, yeah. So this is working pretty well. At the same time, they're closing in on me. They're also not breaking up. You know, they're not like splitting apart or anything like that. And actually, it would be good to test that with more than one character. Just have one character on the one side of the screen and have the other character. Can I just run here? Let's just run. Let's do this. Let's hire one other character real quick. Okay. And we're going to put one on one side of the screen, the other one on the other side of the screen. Let's see what they actually do here. In theory, they should all stay together and probably just choose one target, whichever one is closer, whichever one they happen to move towards. But we'll see. Let's see what they do. And then I'll explain kind of how I did this. Okay, so this one, they'll probably move towards the right then, because most of them are towards the right. Let's see what happened. Oh, interesting. So they're kind of, well, they're not really thinking. It doesn't really think, but they're kind of, yeah. So they're not quite sure where to go. That's probably, yeah. The problem is, okay, that's a problem right there. They're not. It's like they're not quite sure which side to go for, and I kind of know why that is. But they're you know, they're more or less, they're attacking. They're choosing the guy on the right side. So I think it's a little too strong. The formula that tells them to stay together is maybe what's going on. So I can change that. Let's go ahead and change that, and I can see if we get some more different results. I'm going to actually kind of explain like how this works, because I'm actually pretty proud of this. Like, to make an AI, the way I did it last time, and this kind of surprised me because I had forgotten how I did it last time. I thought I knew how I did it, and then I looked at my old code, and turns out that I didn't do it how I thought I did. Basically, if you look at the actual formula or the actual function here, let's see here. I went, and for every move, I gave it, a rating, based on the type of move it was. Let me see if I can find. Okay, yeah, here you see, for instance, the spells. I just went through every single spell and said, okay, what is the type of spell, or the actual spell itself, like the actual. I think I went through the actual spell type cleanse. I had specific spell types in here, and I do some. Look at this. I do some huge calculation for this mother, and then make sure it wasn't like negative or something like that. And it was just me. I did a lot of tweaking with this stuff. I'd like, play a game and then just see how everything, functions, see if it was working like I thought it should, and then I went and fiddled around with the numbers some more, the calculations, for each, like, individual spell, basically. Or it says it's a spell type, but there's a lot of different spell types in the old version. And so I had a lot of tweaking, back and forth, just tweaking. And I didn't realize that I had hard-coded it like this for the previous version. It's kind of surprised me. The new version basically does this. It's a very generalized type formula. It actually plays a turn, basically, beforehand, and it gets the total situation on the battlefield before it simulates that move, and then after it simulates that move, and it takes them both and kind of looks at them and gives them each kind of percentage-wise, or a percentage, and then it takes that and combines it and gives it a rating. And so it's a little bit more. It's a little bit closer to how a chess AI works. The problem with a chess AI is basically brute force. It just takes every move on the board and looks at the result, and then and then does that like for 10 turns in the future. But the problem with that is it's just way too slow for a complicated game like this. In fact, it's nearly impossible. I can look one move ahead, and that's really all I could safely get away with. If I took, for each move, if I took that move and tried to look at all the moves from that move, then it would just be way too complex. Chess is a very, very simple game, and that's why you can essentially brute force it. So I have to come up with some other tricks here. And I've come up with something that's okay. It's actually surprisingly good. Here's the for each move I go into the assess battlefield situation function right here, and basically what I do, this is the ally situation right now, the ally situation in the future, the enemy situation right now, the enemy situation in the future, and I have this list of units that is like the units right now, and a list of units kind of simulated in the future for when the move actually, whatever results the move actually gives, like, decrease in health or increase in health, or the unit gets killed or something like that. So I just go through there and go through this list of units for each of the situations, and I get the strength. And the strength is a very basic calculation. It's actually right here. The base strength is 200 plus the level times 100. So every unit has at least 200 plus, the level times 100. So, if you're dealing with a bunch of units of, level 10, then it's going to be like 1,200, something like that. But anyway, it's just a base like calculation. You gotta have, when you're doing calculations like this, you've got to have, you know, a solid base number that so you kind of know what you're working with. And then it just takes and it gets the percent of you know, basically magic points. It takes the percentage of magic points that you have, and it adds, you know, if you had full magic points, it'd add an extra 10% of the base strength to the total calculation. So I wanted, you know, I want the computer to consider a little bit before it uses magic the cost of using magic. You know, it can't just say, well, I can use a spell, let's go ahead and use a spell. It's got to consider, okay, I can use a spell, but it's going to cost me, you know, a certain percentage of my magic points. And so maybe if I could do it more efficiently some other way, I should. So that's basically what this is doing. It'll give a small penalty for expending magic points. You don't want it too big because you don't want the computer to be too stingy when it's using its magic. You know, it definitely, you know, you want to go for it, and if it can get a good hit in with its magic, you want it to use it. But just a little something to kind of hold it back so it doesn't just blow magic just you know, senselessly or needlessly. And then a new stat added to the game is stamina, and you know, it's one of those things that it seemed like a good idea for several reasons, but I'm almost, right now, I'm still on the fence as to whether or not I'm going to keep this stat. But this gets your percentage of stamina to max stamina, and so, you know, the idea is each move, including using magic, uses a little bit of stamina, and, you know, you can't... if you have stamina drop to 0, you are disabled for a little while until you gain stamina. But yeah, it's like I'm still on the fence about whether or not that's going to be in the final version. But anyway, basically it takes your stamina, your percentage stamina, and you know, if you had a full 100% stamina, then it would add a maximum of 20% of that base strength to your total strength score. So it's in the same way as magic. It's like, you know, if this move expends a lot of stamina, you need to, you know, it needs to be weighted a little bit, so you don't have the computer just, you know, blowing stamina willy-nilly is the idea there. Anyway, and then you take that and you get the percentage of health, and you take that strength score right there, and you times it by the percentage of health divided by 100, and that means basically if you have a strength score of, say, you know, 1,000, right, and you have 50% health, then that'll give you a strength score of 500, right? So it cuts it in half if your health is halved, and if you're not alive, it'll just put a 0 on the strength score, although that's probably not needed, but just for completeness. Anyway, so that gives you a strength. That's how I rate the strength of each unit on the battlefield, and you need that, and that's kind of difficult to come up with. You know, this is probably pretty accurate, but there's, you know, in all the real tough thing with AI is rating the situation. That's the hardest thing to do because, you know, there's so many different factors, and it's not going to be 100% accurate. This is, you know, it's a pretty good guess about, like, the overall situation of, like, a unit, minus, like, what's going to be added later is like status effects, like, let's say poison, or, you know, stat buffs from spells or something like that. You know, there's various other things, but right now, you know, it's pretty simple. It's just, you know, just this. But, you know, it's going to get a little bit more complicated when I start adding, you know, like if a unit gets cursed or something like that, I'm going to add that in here somewhere. But anyway, so you take that, And here's the interesting part. So that gets you, like, let's say the ally, this unit's current situation with his strength there, and then down here it takes that and it runs it through another calculation, basically, which here it gets a rate unit location on the battlefield. So here's the thing. So the old version, you didn't really move at all around on the battlefield. The old version looks like this. So, and I'm sorry, this is ripped off the Apple iPhone site, what's it called, the App Store site. I should have a better picture, but I don't right now. So anyway. But this is what it looked like. These were the hexes, and this was the enemy hex area, and this was your hex area. And if you really want to see that game, there's I have a playlist of me going through that game, Mazequest, and you can, if you really want to see it, you can find it in my my YouTube channel. But anyway, nobody really moved. I mean, you could move to another hex. You could basically just warp to another hex, and it had, like, certain positioning, like one unit was in front of the other, and therefore you maybe couldn't hit this unit if you had a short range weapon or something. But there was no, you didn't have to move to the enemy to hit them. It was a totally different setup. It was basically, it was not strategic at all, the combat. It was kind of just one of those Japanese, like JRPG type setups where you just you maybe have someone in the front, someone in the back, and the person in the front can hit people anywhere or something. Maybe the person in the back can't. Although that wasn't really the situation here. But anyway, we've added, an actual battlefield grid so you can move strategically. And so the difference here is, basically, how to get the units to actually move towards the enemy. It's trickier than you think, because maybe the traditional way to do it would be to say, okay, start this unit's turn, and let's see, where the other units are that he wants to attack, and then how far away are they, and how can we move closer to them, and that sort of a thing. But in this version, or what I'm doing here, is I'm just saying, okay, let's take the max distance of the battlefield. Oops, sorry. So in this case, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 hexes wide. 1, 2, 3, 4, 5, 6, 7. I believe it's 9 by 9. Is it? Yeah, 9 by 9. Whatever. So the max distance that this unit could be from an enemy unit or a friendly unit would be whatever it is. I guess it would be, is it calculated? I think it's 7. I actually have 9 here, but maybe that's wrong, but that doesn't matter. It doesn't really matter. I said the max distance is 9 in this case. So I just keep doing that. So anyway, you get the max distance, and you say, okay, so that's our baseline. A unit on this battlefield can never be, 9 units from, or more than 9 units from another unit, or more than 9 hexes from another unit. Or actually, now that I'm looking at it, that's kind of wrong, because there's an X and Y factor here. So, because you could be right there, and you could be 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, not really. Anyway, there's some kind of factor here where I think you could be more. But anyway, that's what I'm using. So anyway, that's kind of your baseline. 9 hexes. So I have a calculation here that gets the distance between 2 units, and for every unit on the battlefield, basically, I say, okay, if this is two calculations. We have the friendly distance and the enemy distance. So I say, okay, let's take the average enemy distance this unit has for the average distance this unit has from the enemies, and let's save that down here, and then let's take the average friendly distance this guy has from the enemies, and also, well, I'll explain the divided by 3 later, but let's take the average friendly distance, average enemy distance, and let's take that and let's give that a % rating, right? So basically, down here we've got yeah, we give that a %, and then we combine them together, and we average them together. Basically, we add them together and then divide them by 2. Average them together, and so what that does basically, it doesn't let the units. The units want to, if they're too far away, if like this guy is way up here and he's an enemy and he's too far away from me, he wants to get closer. So all of his moves are kind of seen through the lens, or well, that's not really accurate. They're calculated through the lens of him being farther away than he wants to be. So he weights more. He puts more weight on like the idea of moving towards me, right? Unless he's close enough to attack, in which case those attack options are going to probably be weighted more, depending on how effective they are. So anyway, and equally, his distance between his allies are also taken into account. So he might say, let's go ahead and... So he might say, all right, so I've got the option to move up here, up here, up here, or down here, down here, down here. And he picks the one that not only moves towards me, but also kind of keeps within a safe distance from his friends. And so the idea there from a strategic point of view is he's going to move toward me, yes, which he has to do to attack me. But B, he's not going to like break up, get out of formation. So I'm going to be able to pick him off solo, right? And now this doesn't take into account like whether or not he's like a mage or something, someone who's like weak to physical attacks and maybe wants to stay into the back, towards the back. It doesn't take that into account, or at least not yet. Maybe it will in the future. If I have that kind of time, I'm really squeezed for time. But anyway. But you'll notice, so they'll move towards me, but they also won't split up. Like this guy won't go over here, this guy won't go over here, or he won't go like this, and this guy won't go like this. They'll generally kind of group together as a result of this formula, because they also, in addition to trying to move towards me, they also take into account their distance to each other. And I think it might be a little too strong, though, the friendly distance, and so I might actually... crank that down a little bit so they're not quite so hesitant to move forward in that one case where I had 2 people split up. In fact, I tell you what, let's so this is where the friendly distance I divide by 3 to make it kind of less of a factor, but let's see what happens when I don't divide by 3. Isn't this fascinating? This is really cool because I don't have to, if you wanted to make a really good AI for, moving strategic AI for Battlefield like this could take a lot of complicated work, whereas I'm doing it, or at least it appears to work very nice, just how I'm doing it now, and it's really simple, really clean, the code that I'm using, or most of the code that I'm using to, make the move. It's really awesome. All right, so, well, let's do this. Okay, so remember now, I went and took away that divide by 3. So they're considering their how close they are to each other a lot more than they used to be. So this might create a situation where they basically don't get anywhere. We'll see. They're definitely not moving as much as they were. Yeah, see, so they're getting down here, right, which they want to do, but then they get to a certain point where they say, well, we can't move too much farther because, you know, this guy wants to be a lot closer to this guy. They all want to be grouped together, and so it's kind of hard for them to move down, and that's kind of the result of me tweaking that formula. Yeah, so they're not going to actually get here. So let's see. I divide by 3, which I don't like to do because this is a fairly low integer, but I'm going to divide by 4, which is going to... I don't like to... I'm using integer numbers. The reason I'm using integer numbers is basically a habit. Floats are... They're slower. So you see me down here timesing things by 100 before I divide. If I was using a float, I wouldn't have to do that. But the reason I'm doing that is not to lose precision with integers, because if you divide, say, like 20 by 9 or something like that, it'll give you a 2, whereas like the remainder would be completely truncated, and that loses accuracy. So instead of that, I'll times by 100. And, you know, then I'll have, like, 2,000 divided by 9, which is like, you know, whatever, it's 2, you know, whatever it is. But it'll give you that, you know, the rest of the number. It's not 254, but, you know, you get the idea. So that's why I'm doing that. And I'm using integers because I'm afraid if I use floats, and I have this fear from way back, you know, when I started programming. If I use floats, the calculations will become too slow because floats are slower than integers. Although I think, you know, it seems to be doing okay. There's no visible slowdown, so I probably could do it with floats. I just I'm so cautious with that. That's why I'm using integers here. So I'm dividing. This is like this. I'm dividing this by 4, which is probably, I'm losing tons of data there. But let's just see what the result is here. Let's try the same little situation. But it's looking good. It's cool. I love playing around with the AI. Unfortunately, just like with the other game, or with Mazequest, the first one, I don't, you know, really have the luxury to mess with it a whole lot. So I got to get something that just works, and you know, we're going to have to leave it at that, unfortunately. Okay, so interesting. All right. So they're definitely moving down at breakneck speed. That guy's moving that way. Okay, they're just kind of like, are they going to pick a side? Are they going to split up? Let's see what happens. No, they're going to... Okay. Well, that was a little weird. Let's see what happens there. Okay. Oh boy. So he moves over. These guys kind of are not sure what they're going to do. Let's see if they figure it out. This definitely might, because of this situation, we might have to tweak that formula a bit. Okay, so they're going to finally decide to move to the right there. But the fact that this unit is over here is kind of pulling them that way. As you can see, they're stopping, and they're kind of like, you know. So it's not, you know, it's not foolproof. And I'm gonna have to figure out how to deal with this kind of a situation. Yeah. So we're gonna have to tweak some more here to make sure they just what we wanted them to do is we want them to just pick a side and go for it, instead of kind of staying here and you know, just kind of not moving as much when they get down here because okay, well, really? I'm kind of surprised he did that. So he hurt his own guy with that spell, despite I'm kind of surprised that was he thought that was the best option. So they should all move over here at breakneck speed now. Yeah, that was interesting. Why did he move to the left? Somebody in his way? Okay, well, he's moving that way now. Oh, interesting, interesting. Well, so it needs a little work. It's doing surprisingly well, though, considering the fact of how simple it is. Yeah, so they're definitely following me, but they're not following me as fast as they probably could or should. Is the thing. All right, so that was it. They killed me. Anyway, let's see. Maybe I should show off some of the spells, or did we already do that last time? I don't remember. Okay. So these guys were here. Let's go ahead and do this. Okay, well. Oh yeah, this is the attack, by the way. That's what it looks like. That's what a dodge looks like. So this is new stuff. Kind of interesting why they moved like that. But anyway, keep in mind that they're trying to stay near each other, and they're also trying to stay near us. So I'm not sure why the barbarian didn't kill me. I should be dead by now. 0.4 out of 1, yeah. Maybe he thought that he couldn't kill me. Ooh. Critical and killed him. Well, I'm getting 2 turns because I have a fast speed. I have like double the speed that they have. Or actually I have 7 speed, they have 2 speed. Yeah, actually more than double the speed they have. Well, let's all go down in a blaze of glory here. Actually, Purify, does this heal anymore? Or does this heal? Did I implement this? Let's see what that does. Oh, it does heal. So does that really mean that healed? Yep, that worked. Hey, what do you know? Yep, that healed everybody. It shouldn't have healed everybody, but it did. There's a bug. Oh. Wow. So, I mean, this is good enough. Like, this beats, you know, like, what, typical AI in an RPG, I guess. Most RPGs is already, yeah, I've already beaten the AI in most RPGs as far as I'm concerned, so, but I could do a little bit better, and I'm going to keep working on it a little bit. I don't have much more time, though, so we got so much other stuff to do. Okay, well, I hope you guys enjoyed that. I love talking about AI in particular. I think is fascinating. Anyway, I'll keep posting regular updates here as I get this game further and further along. And I guess thanks for watching, and stay tuned for the next one.